All right, so today we're going to tackle a really strange puzzle, one that's right at the heart of AI. You know, how is it that a machine can pass the bar exam, but it can't even load a dishwasher? It's a weird one, right? Let's dive into this whole quest for what you might call artificial common sense. Okay, so this first part is all about what I like to call the smartest clumsy machine. Because it really all starts with this weird paradox in modern AI. These systems, they're absolutely brilliant, right? And yet, in some super important ways, they're just incredibly clumsy, and this really gets to the core of it. Why can a house cat, your average cat, outsmart the world's most powerful AI? I mean, seriously, just think about it for a second. Your cat can navigate a messy room, it can hunt, it can play, it plans out a whole series of actions without even thinking. It's got this deep, intuitive grasp of the physical world. So why do our most advanced billion-dollar AIs completely fall flat on these seemingly simple tasks? And this right here just lays it all out perfectly. We've got AI today that can absolutely master these incredibly complex, abstract things. Like a legal exam. I mean, that takes a huge amount of knowledge and logical reasoning. And yet, a simple task like loading a dishwasher, something, a 10-year-old can do without even breaking a sweat, it's completely out of reach. It's just bizarre. Well, believe it or not, this whole phenomenon actually has a name. It's called Moravec's paradox, and AI pioneer Yann LeCun puts it perfectly here. He says, the things that are super easy for us humans, just seeing things moving around, are brutally hard for machines. And the things we find hard, like crazy advanced math, that's trivial for them. It's completely backward. I mean, for years, right? We've all been promised these amazing things, like fully intelligent robots and true self-driving cars. But the fact that they're just not here yet, it tells you that something major, something really fundamental, is missing from our current AI. So what is it? What's the missing piece? Well, the answer, or at least a huge clue, might come from looking at the most powerful learning machines on the entire planet, human babies. So the idea is this. Instead of just force-feeding AI more and more text, the entire internet, maybe we need a totally different approach. Maybe we need to let it learn the way a child does, just through pure, simple observation. I mean, by just watching and interacting with the world, a baby builds this incredibly powerful, intuitive understanding of how stuff works, and nobody's giving them a textbook. And just look at this timeline. It's fascinating, right? It shows you how structured this whole learning process is. At just 2 months, a baby figures out object permanence. That stuff still exists, even when you can't see it. A few months later, at 6 months, they're getting a handle on support and stability. And by 9 months, they've got an intuitive feel for gravity. They are literally building a mental model of physics, just piece by piece, by watching. Okay, so you might be thinking, hang on, isn't it all about the data? I mean, large language models, LLMs, they're trained on these just unimaginable amounts of data, right? And yeah, that's absolutely true, but what if we're measuring the wrong kind of data? So get this. A top-tier LLM today might be trained on something like 30 trillion tokens of text. That's just an astronomical number. To put that in perspective, that's like a person reading for 12 hours a day for 450,000 years. It's insane. Okay, but now look at this number. This is how much sensory data in bytes a 4-year-old processes just through their eyes alone. It's way, way larger than all the text data we're feeding our biggest AIs. And that right there, that is the really mind-blowing takeaway. When you're talking about the sheer volume of information about how the world actually works, a little kid has a massive, massive advantage. Sensory data, seeing, hearing, touching, it's just so much richer than text could ever be. So what all this is pointing to is this core idea, this thing that AI really needs to learn. It needs to build an internal model of the world. You could almost call it an AI's intuitive physics. So what is a world model? Well, think of it like an AI's internal simulation, a little movie it runs in its head to predict what's going to happen. It's not just about, recognizing a ball. It's about understanding the rules, that if you drop the ball, it's going to fall. This is the AI's version of intuition, and it's the absolute bedrock for building any kind of real common sense. And if an AI has a really good world model, it can start doing all these things that are basically impossible for it right now. We're talking about learning physics just from watching YouTube videos, or planning out all the complex steps to, load that dishwasher. It could reason its way through brand new problems and ultimately actually work towards a goal in the physical world. Okay, but building these world models, it's really tricky And it turns out that the most popular ways we build AI today, they're just not going to cut it for this job. Let's dig into why. So right now, the big thing in AI is something called generative models. If you think about trying to predict the next frame of a video, this kind of model literally tries to guess what will happen by predicting the color of every single pixel, the whole picture. And here's the problem, which you can kind of see in this image, that the real world is just way too messy and unpredictable. Trying to predict every single tiny relevant detail, like exactly how every leaf is going to rustle in the background of a video, is just an impossible task. The model gets totally overwhelmed by all this uncertainty, and it ends up just predicting this blurry, averaged-out mess. And yeah, LeCun is super direct about this. He basically says, generative architectures just do not work for images and video. And why? Because the world is only partially predictable. The real trick isn't predicting everything, it's learning what you can safely ignore. So he proposes this totally different approach. It's called the Joint Embedding Predictive Architecture, or JEPA for short. And this is really the aha moment. Instead of predicting all the messy pixels, JEPA learns to predict a high-level, abstract representation of what's going to happen. Think of it like this. It's not trying to predict the exact position of every pixel on a falling ball. It's just trying to predict the concept that the ball will be down here in a moment. It's all about the essence of what's happening, not the noisy details. So here's the difference in a nutshell. Generative models get totally bogged down, trying to guess all the unpredictable noise. JEPA, on the other hand, learns to focus only on what's predictable and what's important. I love this analogy. It's like summarizing the future, instead of trying to paint a perfect photorealistic picture of it. And that right there is a huge shift in how we think about this. And this new way of thinking, this architecture, it opens up a completely new path forward for AI. This could be the breakthrough we've been waiting for, the thing that lets us build robots that can actually safely operate in our homes, or self-driving cars that can really handle the chaos of a real city street. So how does it all come together? Well, an AI with this kind of world model can start to think in a much more structured, almost human-like way. It's a three-step process, really. Step one, it perceives the world. It sees what's going on. Step two, it uses that internal world model to simulate, to imagine what would happen if it tried a few different things. And finally, step three, it just chooses the action that it predicts will get it closest to its goal. And this brings us to one last big thought. You know, building common sense into AI, it's not really just about making a robot that can finally load that dishwasher. It's about creating systems that can genuinely plan, reason, and solve problems out here in our messy, complex, unpredictable world. So if we actually pull this off, what are the big challenges, the things that seem impossible today, that might just become solvable tomorrow?